Hello, hello. Haju1, hello. How are you doing? Okay. Today I'm working on cast again. Okay. Let's see. What happened last time? So I was working on the movement semantics on my programming language, right? We have a lot done. A lot is done. My tests are currently not working though, as far as I remember. So I should fix the tests. But also I was thinking about one thing. So like right now, the move semantics is basically same as in Rust, with maybe the exception of the fact that um like I can have the copy types be more than just bitwise copies. Although not yet actually, because I cannot implement my the trait myself. Yeah. But it basically like is the same as in Rust. So here's one thing though that is missing from Rust, I think. It is working with in-place initialization of values. Rust in place. If I search for Rust in place, in place operations. I should also look at how C++ does that, right? Because C++, I'm not sure. I think you can do in place. In place initialization, like what am I looking for here? In place initialization has to be unsafe. I'm a C++ guy who has been playing with some Rust programs. My current sticking point going over the constructor concept to Rust. Does Rust allow in place initialization without resorting to unsafe? For large arrays of struct. If unsafe is required, is there any effort to allow safe in place initialization in the future? Placement new. Yeah, there we go. Placement new. Which has an RFC. Oh, Nertzel. Overloaded box and placement in. This has been merged. Does it mean that this RFC has been accepted, right? Or is this closed? No, it's merged, right? It's merged, which means that here's the tracking issue. Tracking issue though has been closed. Why? Is it because it was implemented? Placement new is about to be, has been removed as an unstable feature, and the RFC unaccepted. Oh, okay, so they accepted the RFC and then they unaccepted the RFC. Okay. You can use summary comment over here. Find the internals thread where you can discuss this more. Removal and unstable placement features. Placement new is imminently about has been removed, unaccepted. Note that this does not affect box syntax. So why remove placement? The implementation does not fulfill the design goals. As described as over there, the implementation of placement new should add user-defined placement in expression, more succinctly, an in expression, an operator analogous to placement new in C++. This provides a way for a user to specify how the backend storage for some datum should be allocated, that the allocation should be ordered before the evaluation of the datum, and that the datum should preferably be stored directly into the backend storage, rather than allocating temporary storage on the stack and then copying the datum from the stack into the backend storage. Yeah. The summarized goals are to be able to place an object at specified address Why didn't you provide a Dwingles line? I just did it. It still is not the end of the Ludum Dare, right? Pomo is doing it for the Ludum Dare. He sent me a message like at 1 a.m. when I was sleeping, so I just did it like 5 minutes ago before starting the stream. Hello, Brainoid. So you can put it into the game still, but you're late. Oh, into the dubstep song? Alright. Well, that's too late then. I thought it was for the Ludum Dare. But yeah, I was sleeping, that's why. This time it was not because I was lazy, Brainoid. Believe it or not. You slept through D2 Jam results? Well, I didn't participate in the D2 Jam, right? Because I did not make a game. But, I mean, I would sleep though anyway, I think. I guess. Sleep is important, right? You was also sleeping? Did you win, Nerdsoul? Did I play your game, Nerdsoul, even? I don't remember. Where is the results? How do I find the results on this website? Congratulations. The post by Honest Dan. Navbar? Which one of these is the Navbar? Discord, Blue Sky, YouTube, Forge. Games, oh, results, there you go. It's literally at the top. Alright, so you won. That makes sense. That makes sense. That's a good game. Pomo's game is pretty high up there. I did not play these ones, though. I didn't play a lot of games. Good boy. I did not play that either. It doesn't say whose game it is. I don't know if I want this information on the results page. Makes sense, Jam is rigged. Indeed, indeed. So you just got access to the backend and you increased your scores. Right. Literally hovered over it. I mean, I don't know. How do I hover over your game? I don't know what it is. It doesn't say. I need to like look at a user here, right? To do that. User Nerdsoul. Check out my cool stuff. Fake. Oh, that's right. And then you cannot see it without being logged in. And I need to go back. Bum, bum, bum. I like this graph though. This thing looks nice. For scores. Wait, what's that? What's that button? Oh wait, you crashed the game with this score? Lol, okay. Funny. Funny. Alright. Maybe I'll play it at some point, but not right now. Okay. I'm going to investigate this a little bit, the placement semantics. Might make a post-gen version. I think I will not be doing any games until we release Linksider. Like, how about we don't do any new projects until we release Linksider? So I'm just not going to work on Linksider, and I'm going to work on Cast instead, right? So that I never need to make a new game anymore. Sorry, I needed to laugh. Brainoid. No, it's going to be released soon. I mean the demo. Yeah, we already we have a date. I don't know why we don't release it immediately, but we're just waiting for no reason. Yes. Martin Janisek, hello, thank you for the follow. Oli, your 50th programming language. What do you mean my 50th programming language? That's my first programming language. I don't think I made the programming languages before, did I? I mean, I did some like very, very, very simple stuff, like a calculator before. I don't think that would be considered a programming language, so that's my first one. At least the first one that I'm making. Oh, my title says number 50. Yeah, it's the stream number 50. It's not my 50th programming language. All right. Making a new language every day. Yeah, that's what we're doing. All right. Anyway, so what I'm doing right now, I'm trying to look into um the placement thing. Placement new syntax, right? Not syntax, like semantics, and whether or not I want to have it myself. I was somewhere else. There you go. So they accepted the RFC in Rust and they unaccepted it. I'm just trying to see. Maybe I should look into how it's done in C++ too. I don't think I ever used the placement new in C++ either. um. So the summarized goals are to be able to place an object at a specified address, references the original C++ goals, allocate objects in arenas, say references and original goals, be competitive with the implementation in C++. Now consider the description of C++ behavior in over here, placement new, and know that during construction that this pointer will point to the allocated location, so that all the fields are assigned directly to the allocated location. It follows that we must provide guarantees to achieve goal 3. So the preferably the implementation description not strong enough, it's actually necessary. So I guess the implementation was different. So in C++, let's say C++. What is this? An empty page. Is that the website for the standards of the C++, and it's not even working? Is it sec faulting the C++ website? What's happening there? Let's search C++ placement new. Placement syntax. There's a wiki page about it. In C++ programming language, placement syntax allows programmers to explicitly specify to the memory management of individual objects the placement in memory. Normally, when an object is created dynamically, an allocation function is invoked such that it will both allocate the memory for the object and initialize the object within the newly allocated memory. The placement syntax allows the programmer to supply additional argument to the allocation function. A common use is to supply a pointer to a suitable region of storage where the object can be initialized, thus separating memory allocation from object construction. The placement versions of new and delete operations are functions known as placement new and placement delete. The new expression, placement or otherwise, calls a new function, also known as an allocator function, whose name is operator new. Primarily, similarly, a delete calls a delete function, also known as deallocation, which name is operator delete. Any new expression that uses the placement syntax in a placement new expression, and any operator new function that takes more than the mandatory first parameter, size t, is a placement new or a placement delete function. Functions. The placement new are overloads for the non-placement new functions. The declaration of the non-placement new functions for non-array and array new express respectively are this. What is this argument? What is the size t there? This throws bad a lock. The standard C++ provides two placement overloads for each function. Their declarations are operator new, const std no throw t, void star. So void star, this means that this is the place where, this is the pointer to the place where I want to initialize the object, right? In all of these overloads, the first parameter is of type size t, which when a function is called will be passed to an argument specifying the amount of memory to allocate. All of the functions must return type void star, which is a pointer to the storage that the function allocates. There are also placement delete functions. Use. Placement syntax has four main uses. Default placement, preventing exceptions, custom allocators, and debugging. The placement overloads of this that employ additional void star parameter are used for default placement, also known as pointer placement. Their definition by the C++ standard library, which is not permitted for a C++ program to replace or override, are. What? It's very difficult reading this. I don't understand what it's trying to do still. I think I get the idea, but by reading this, I have no idea still. Calling a constructor directly, something which the C++ language does not otherwise permit. Use case. Placement new is used when you do not want operator new to allocate memory. You have pre-allocated it and you want to place the object there. But you do want the object to be constructed. Typical situations are: you want to create objects in memory shared between two different processes. You want objects to be created in a non-pageable memory. You want to separate memory allocation from construction. For example, in implementing an std vector. See reserve. The basic problem is that the constructor is a peculiar function. When it starts off, there is no object, only raw memory. And by the time it finishes, you have fully initialized object. Therefore, the constructor cannot be called on an object. However, it needs access to the non-static members. Makes calling the constructor directly an error. The solution is the placement form of the operator new. Operator new here, return here. I still don't get it. Maybe I should read the standard or something. Normally, the non-placement new functions throw in exceptions of type beta lock. If they encounter an error, such as exhaustion of all available memory. This was not how the functions were defined by Stroop's annotated C++ reference manual, but was a change made by the standardization committee when the C++ language was standardized. The original behavior of the functions, which was to return a null pointer when the error occurred, is accessible via placement syntax. Programmers who wish to do this in their programs must include the C++ header new. The header declares the global non-throw, which is of type no-throw team, which is used to call the overloaded new functions. Placement syntax is also employed for custom allocators. This does not use any of the allocator and the allocator functions from the standard, but requires that programs write their own allocation and deallocation functions, overloaded for user-defined types. For example, what could define a memory management class like this? A. Beautiful name. That's, yes. All right. So I have class A, which is an allocator. And define custom placement, allocation, and deallocation as follows. Operator new A arena. I thought this must be a void star, but I guess you can like have anything there. Right? Okay. That makes sense. So you allocate in the arena. The program will employ the placement syntax to allocate objects using different instances of the A class as follows. New first arena T, new second arena T. Destroying an object whose storage is located in such fashion requires some care because there is no placement delete expression. One cannot use it to invoke the custom deallocator. One must either write a deconstruction function that invokes the custom deallocator, or call the placement delete function directly as a function call. That's how you call it. No, that's the destructor. That's not calling the placement delete function. Be invoked from a program like this. Yes. When I was playing with Zig, they were storing the allocator inside the object, and yeah, I was saying that it has a downside that you basically store extra data, and you're wasting memory by storing where the object was allocated inside the object itself. But on the other hand, if you do it the other way, which it seems to be the C++ way, then you need to like manually ensure when you're destroying the object that you're destroying it from the same allocator, basically. Operator delete. That's how you do it explicitly. Okay. All right, I see. Yeah, that's why it's returning the pointer, right? Because the argument here is not always the pointer. Some good news, a big YouTuber played your game yesterday. Nice. The Aliens Rock? That one?
This is a tile matching roguelike with
Yeah, I think that this one was saved for me because it plays a lot of puzzle games, right? Or does he just play all the games? Right. Nice. Good for you. Did you just write to him, or did he play the game like on his own, or did you tell him to play? You didn't email? No. You don't know where he found the game? Okay. Well, I mean, since this is the content that he's making, he's actively looking for new games, right? To try and make videos on, I guess. I don't know. All right, so maybe we don't need to mail him either. We just need to release the game first. Yeah. But he was on my list. Of 3 YouTubers, I think. My list is not that big as yours. All right. Anyway, so we I don't think I'm going to like implement anything regarding the placement today. I just want to think about it. So I want to understand what is trying to happen. Right. So the core idea is that, let's say that in Rust we write something like this, you know, like A is let's say it's a boxed something. It's a boxed slice of integers, right? So I can say box new, and then as an argument something like 1, 2, 3, 100,000, right? So this thing, the way it works is at least like before the optimizations, is timed out. Wait, why did it time out? What? Release. Does it work in release mode? The operation timed out? Okay, there you go. It works in release mode, but not in debug mode. Okay. Is it the allocation timing out here? Wait, what? Or is this not being optimized at all in debug mode? So anyway, we are making this object on the stack, and then we're passing it as an argument to the function, which is called box new. I am pretty sure this box new is like special cased, but in case of other ones, right? Let's say that I have another function create box, right? And this takes in an array for 1,000. This returns box, right? Box new A. If I do it through another function, is that going to say something like Stack Overflow? It's not saying Stack Overflow. Is it actually inlining it? How do I show the problem? Maybe it's just not enough. Let's have more. What's the normal stack size? Seg fault, sig abort program, right? Is this the thing? If I run into the release mode, then it works. Okay. Let's try this in here. I'll go run in place. Yeah, so it says Stack Overflow, right? So the reason is because we are actually allocating this object on the stack, and that's the problem. right? So how do we so what we want to do is we want to allocate the box first and then put the data in, right? Let's look more into what happened in Rust. The functionality of placement is unpredictable. As described in C++, goals for placement. Placement is typically used because you need to have explicit control over the location an object is put at. So above that, Rust fails in very simple cases, but even if it didn't, there was a more general rule. There is no feedback to the user whether placement is actually working. For example, there is no way for a user to tell that linked list back place is placed. But this is not. Okay, so they have like the backplace method, right? So a method that returns a place, and then you have the placement operator. Is that how it was supposed to work? Actively placement is implemented today is a slightly better effort to place values than normal assignment. For an API that aims to offer additional control, this unpredictability is a significant problem. The RFC might provide either provide clear guidance, something, specific unresolved questions, making placement work for 30 with failable creation. Is there like any research? So this was unaccepted in 2018. Placement new. It is common in game development to want fine-grained control of where values are allocated. This would commonly be used in object pools ECS systems. Support for this used to exist, but was removed. The reasons are summarized here, possibly oversimplified. The controversial expected new syntax does not accept a reference to self-constructing explicitly, always goes to the stack. For example, the type, and neither of these allows for the allocation to fail. So it's unclear how it would be implemented in a way that is reliable. I do not see any recent activity working on this. It is possible. It was from 2019. Maybe uninitiated and unsafe code. There is a bit of support that landed in the compiler. It APIs for uninitialized box, RC, and arc. Okay. That's how you create the place, I guess. The discussion on Zulip about placement new. How to read this, top to bottom or bottom to the top? Revisiting placement new. Place arrow FX. Is there an equivalent of placement new in Rust? From 2 years ago. Rust really doesn't have placement new, sounds sus. Can I create an object in specified memory location, be it safely or unsafely? If you have already initialized it and provide a mutable reference to it, and the reference it then assigned to safely override the existing value. If you have an uninitialized location, you can use pointer right. This is obviously unsafe. Hello, Veldak. Rust secret weapon. Power placement new slashed our memory usage by 40%. If you've been working with Rust for a while, you might think that you know all its memory management tricks, but there is one powerful feature that flies under the radar. Placement new. Understanding the foundation. Before we dive into the placement new, let's establish why it matters. In standard Rust code, when you create a new object, the memory allocation and object construction happen separately. Allocate memory, then construct. Well, technically, this is two separate things. We first construct and then we allocate and move it into the allocated memory, no? Because this happens first. This two-step process can be inefficient. Hello, Pigorlin. Especially in performance-critical scenarios. Placement new combines these steps, allowing for more optimized memory usage. The core concept, placement new enables in-place construction of objects at a specified memory location. Placement new protocol feature. I thought it was removed, or is this the new thing? Think of it as telling Rust exactly where to build your house instead of letting it choose the location for you. Here's a simple example to illustrate. Place new will implement the placement new for the structure. Implement stdops place point. Plus A. What does this mean? Setting up the infrastructure. To implement placement new, we need to understand the three key traits: place, placer, and in place. Wait, is this like a new thing? Placement new protocol Rust. This is from 1 month ago. RFC's placement left arrow. Place expression, value expression. Place left arrow syntax. That's a different one. Placement new protocol. It's not even... Yeah, it's not even here. Just nightly features. Unstable features. Reference unstable. I don't know. Anyway, let's see what they say here. Setting up the infrastructure. We have three traits: place, placer, and in place. Here's how they work together. We have a place T, which has a target, a pointer. Hello, Ogma. Then we have create an account, read the full thing. What? Become a member to read the story. Okay. Delete. Cannot even read the thing. Another idea for placement new. We just need to extend move analysis with two things. This works today. S is my struct. Move the fields out of the struct. Move the values into the struct. Rust ensures that all fields are present when a useMyStruct is called. What's missing is a way to create a struct instance without the fields. And a way to initialize it from another function. This can be solved with what I call move references. What's a move reference? A move reference is similar to a mutable reference. However, it can be uninitialized at first. Once it has been fully initialized, it turns into a normal mutable reference. Move references need to be linear types. It's going to is that functions that accept a move reference and do not return it to initialize them, we can deduce from lifetimes. How would this work with box and vec? Move references can be created for row pointers. It's possible to allocate memory on the heap and obtain a move reference to it. So box init initializer fn once using the move reference. How can we enforce that move references aren't dropped? The problem is that values of generic types can be dropped, like here. We need to make it impossible to call drop with a move reference. This can be achieved with a destroy auto trait. What about types other than structs? Okay, this actually is similar to what I had in my mind. So in Rust right now, you can only have references to initialized data, right? Yeah. And we want to be able to have references to the non-initialized data and then initialize it through the reference. That's basically it. But yeah, the better name is an out reference. I'm going to make it impossible to do this. This does not account for implicit drops due to unwinding. Alright, but I think with like truly linear types, where you guarantee that something is used. Not sure how it works with unwinding though. Partial initialization should be possible. Yep. Okay. Targeting foundational software. Oh wait, that's a recent one, relatively. Targeting foundational software. There is a placement here. No, there is nothing about the placement here. The whole stack. No stable allocator API, no placement new. No take away to allocate things on the heap without them be going on the stack first. And trace will only work for tuples up to length 12. Almost no operations are permitted on const generics. The list goes on. That's why they still use C++ instead of Rust. No placement new and no not hacky way to allocate things on the same on the heap without them going to the stack. Aren't these the same things? No. You can get the same behavior using maybe uninit. But a language level solution is needed. Yes. There's some macros in the on the crates.io for placement. They say placement new. Common utilities to implement placement new to drive. So the archived thing. And the crate was removed. Yanked. Okay. All right. Maybe I'll keep looking at it. But it is something to think about. Also, there is another thing, which is I am treating everything as a move, as a type that can move right now, right? So similarly to that, I should be able to have the non-movable types. If we talk about the that stuff there, so like there's placement new that I need to look into, and the and non-movable types. Another good thing to think about is the linear type, which like must be used. But anyway, let's stop with the thinking, with the research, I mean. And I guess I want to fix the tests. Fixing the tests is important, right? So that right now they all failed. Why do they all fail? Let's go one by one. Cargo just run. Example. Mutual recursion. So this one says, for example, that I cannot hash global contexts. Let's see what this is about. This is the example of mutual recursion. We create a recursive scope where we define two functions that call into each other. So the thing is, I'm trying to, yeah, so here's what's happening here. That makes sense. I'm constructing this object, this recursive object, and then I'm assigning it into the variable, right? So when I'm assigning things, I always need to know if I'm moving it. Or if I'm copying it. So I'm trying to figure out if this type is copy or not. Yeah, I'm trying to figure out if this type is copy or not. And this. It probably should just be not copy. Let's take a look. Is copy over here, right? So I'm trying to see if this type implements the copy trait. In order to figure out if the type implements the copy trait, I'm trying to see if the type is fully inferred. Or not. This says recursive, even though this is not really recursive, by the way. But it's fine. So the problem is the contexts of the function types. This is not inferred. Is this the problem with inference, or should I just treat that as a non-copy type? Technically, this has been compiled, right? Yeah, I think that's what I don't have right now. Don't have inference for contexts. Kind of just want to treat it as a non-copy for now. Like, what should I be implementing my traits for? Only for custom types, right? Anyway, only for custom types. All right, I need a break. Or 5 minutes rather. Hello, Nigel. Ogma's Dwingles was best. I didn't hear the Dwingles, by the way. Where is it supposed to be? Maybe somewhere on the D2 gem? I don't know. Guess who's back? Back again. Java Dev is back. Tell a friend. Alright. Nothing useful has been done so far today. So I should start doing something, you know? What should I do, though? That's the question. So right now the tests are broken because of the copy trait that that we have. But right now, determining if something is copy or not requires this to be you did another win in Neuten, number 30. Nice. Nice. I saw your win to number 29. I launched Neuten directly, like immediately after I saw your post about win number 29. I went into the cave and then and then I had the physics issue like immediately straight out of the gate. Like the thing just flew without me kicking it for some random reason, and I closed the game immediately. Alright, that's what happened. I was thinking that I should get another win for myself too, but no. The physics told me that that was not the day. You know, like the first thing that you see when you enter the cave after the tutorial is some object that you can push. So yeah, I just went to it. I was stuck in it for a second and then it flew. And I just, nope, not the Noi today. All right. Back to coding. Yeah, back to coding. All right. So what do I do? What do I do? What do I do? So right now, here's the cast, right? Cast. This is the casting implementation. I'm trying to cast the type into the copy trait, right? To see if it implements copy. And if it doesn't implement copy, then we say that it doesn't implement it. But we expect this to be inferred right now, right? We expect it to be inferred, but it's not fully inferred right now, and that is the issue. At least it's not fully inferred, right? Which is why I cannot get a hash of it over here. Yeah. So one thing that I could do is what? Maybe I should just continue this thing. So right now, for tuples, I say that they are not recursive always, right? I don't say anything about them, the tuples, but the tuples, they should be copy if every field of it is copy, right? So that's what I should do actually. Yeah, that is literally what I should do. Tuple. I should say here for field in tuple Do I do this? What is the field in this case? Consider removing. Okay, hold on. So tuples. I iterate over the fields. There is unnamed. There is named. There's asref. There's values. Okay, I guess values is what I need. Yeah, because I don't truly care about the names. That's right. So I say for field in tuple values. In this case, field is another type, right? I say if let sum is copy is self.isCopy field, right? So if a field is copy, or like if some field is guaranteed copy, no, hold on. If we what should this say? I should match this. If the field is copy, then I don't really know anything, right? I need to continue. If I know that the field is not copy for sure, then we return that I am also okay. Wait, hold on. This should be also optional. Yeah, I mean technically just all of the fields should be copy here. That's what I'm doing. Yeah, hold on. We just say tuple values dot all field self is copy field. That's all that I need. But that doesn't work because this returns a result. And Rust is stupid. Okay. So I just return true. And then I say that if not is copy field, then I return false. Okay. And then I treat all of the functions as copy regardless of their types right now. Good enough for now, maybe. All right, so now this actually worked, but then I don't have the but then some panics at runtime expected a reference to string got string stdlib 61. All right, let's see, stdlib 61. What is that? Oh, output write native dbg value. That makes sense. Yes, that does make sense. So dbg is a function that returns a string, not a reference to string, but a write is something that requires a reference to the string. The reason it fails at runtime, though, is because a native expression is evaluated at runtime right now. Should it be evaluated at runtime? And not at compile time, I think. I mean, yeah. Kind of depends on the target. But anyway, the DBG is needs to be taken a reference here. I need to take a reference there, yep. And over here too. There you go. So now we have a mutual recursion work again, cargo test. Maybe this also fixes other tests. So I just all I did is figuring out if a tuple is copy, and it's only copy when all of its fields are copy. Okay, we have 3 more tests that fail. Sure. And then also some of them are hanging, which means that there are more. The fact that they are hanging also is weird. But let's try running the local syntax. This one says also cannot hash global contexts. Failed to claim. That's right. Source interpreter 1425. It doesn't say when. A local syntax. Let hello be this. Let world be that. Both is a macro. Interpreter 1425. Claim value expect failed to claim. That's right, yeah. Russian result. Then we had the backtrace here. Rust backtrace is 1. Not working. It doesn't really show me the line of code in cast though. This should return a result then. No LSP references found. Wait, what? Is my Rust LSP even working? Yes, it does. Because I need to search for the original method. Okay, from ref. Yeah. I think over here I just say question mark from reference must be like potentially throwing an error. So I just say like that. Claim value already returns an error. Yep. And in this case, it's okay immediately. Consider further restricting. Self is sized. Sized. Sure. What's wrong with the syntax highlighting here again? All right. In built-in macro constlet at line 1. So literally the first line doesn't work. Okay. Literally the first line. What do I have in the first line? I have a macro. Okay. Yes, I have a macro. Is copy. So if I have a macro, then it says none. But I guess I just say true here. I think I just say true there. Okay, that works. Might need to change that in the future. Maybe. Okay, 2 more failures. Reno's favorite Dwingles is Pigorlis, sexy one. Alright, where do I hear the Dwingles though, Brainoid? You can send it over. Is it private? So it has not been published yet? Okay. Macro hygiene. Let's run macro hygiene. This one says the place has been moved out. Read ref expression at macro hygiene line number 9. Macro hygiene line number 9. So here we go, right? Here we go. We have a macro called name. So this name is an AST. Yeah, there you go. So this is an AST. AST right now is also not copy. But I guess, wait, do I just make AST copy in this case? Because that's how I write macros. Well, I mean, technically, I don't need to copy them here, right? In order to generate this code, I can have this a reference. So this can be a place expression, kind of. Right? So I only need, like, the full definition here is that name is AST. So this should only refer to the name by reference and not try to take ownership of it, right? The song is a little bit distracting, need to warn me. I think I'm going to be distracted by some song. There's no way. I'm hyper focused right now. Alright, so like there's 2 solutions to this. I either make the AST copy or I make this to need a reference only. Which makes more sense to me. Maybe. So I say that in the compiler, right, I have the unquote, right? So this is the unquoting inside a quote. I compile this as an expression. Right? Okay, this returns an expression, yes. Hold on, quote returns an expression. And inside quote, I have inner expressions, which can be place expressions. So I have an expression AST, which has values, which is a tuple of expressions. Those could be a tuple of place expressions. Right? So I evaluate them as references. To ASTs. But then I construct a new AST. Yes, okay. Kind of makes sense to me. Let's try changing this type, see what doesn't compile. So over here, yes, values. Value is a quote there. Okay, but that can be... I don't know, so do I just return place expression in this place? But this is an expression, right? Yeah. Expression constant AST. Place expression, new temporary. I guess in this case I make a temporary constant. In this case, I also make a temporary. Expression. And then this also should be a place expression. Place expression, temporary. Does that make sense? No, say expression. No, hold on. I need from a place expression to make a new a normal expression, which is a expression read place, right? Expression read place, where place is this. Maybe I have a constructor for it. Let me see. Expression read place. I don't really. Okay, so we say expression read place. Place is that. And data is span. Init wait self. That it. Okay, and then if I have an AST expression, the values inside are potentially place expressions. So AST values right now is a tuple to AST. Is a tuple of ASTs. Yes. But I need to not copy that. That can be a reference. Although in this case specifically, I am going to clone them when I'm constructing a new AST. This is where I clone them. Yeah. But in general, ASTs are not. Copy, I guess. Replace. So evaluate place is a place. And then inspect. Right, because I need to read the value and then clone it. Like that. Does it work? It does work. So here's the thing. If I have an AST, right? Let AST be a quote like A plus B plus C, right? Then this AST is looking like that, and that AST is not a copy type. So I can say let AST2 be equal to AST. So AST has been moved out now. It exists in AST2. Yes. But if I construct a new AST, AST2. So if I construct a new AST by quoting the AST2, I essentially just clone it. So, and they both exist? No, they actually do not both exist. Wait, why not? Why not? That's weird. Or is it specifically because it was a root? Hold on, maybe I have a bug. If I say AST plus 3, then AST exists still, right? And AST2 also exists. So that's when it's cloned. Is it because I'm quoting and unquoting immediately? Maybe. Let me see. So if when I'm compiling here, expression root boolean, so I know that this is immediately the unquoting. Yeah, that is exactly what's happening. Yeah, the quote unquote immediately doesn't work. Not a big deal, but I should fix it. Where is expression root being used? Over there. Wait, what is happening? If it's to the root, I'm trying to quote something, which is immediately doing the unquoting. I'm compiling that expression into a place expression, right? So it is a place expression indeed. But then I'm reading the place. That is why, because I'm reading the place here. Yes. Even though that is a place expression. Yeah, so reading place claims the value and moves it out. What do I do about it? So do I need another expression which is not reading but always cloning the value in a place, even if it's not copy? Would be weird though. That would be weird. Maybe the like this should always result in an AST expression, I think. But AST expression is constructing some specific syntax definition. If I quote unquote immediately, then we don't have it. Okay, you know what? I think I don't care about it too much. I just have a to do. To do quote unquote moves x. Good enough, I think, because I don't like, you don't usually write quote unquote immediately. I can fix it later. Okay, so hash map. What's wrong with hash map? Maybe because did something typo is not inferred, failed to hash, place has been moved out. When compiling, instantiate template at stdlib 187. stdlib 187. Over here. Oh, this is a for loop. Okay. This is a for loop. Just trying to compile this. Fail to compile function. In macro type ascribe, failed to evaluate the type. Is this the thing? Body result? In built-in macro type ascribe 187, 17 to 45. (17 to 45). Yeah, so this thing doesn't compile. Body result is body result underscore. It doesn't compile because it failed to evaluate the type. It's trying to instantiate the template here. And when so like this is instantiating the template with the not inferred type. It specifically is underscore here. So it should be inferred, right? And then so I'm trying to compile instantiate template. Cast key. Is it trying to see if this is copy or not? I think that's what's happening. It's trying to see if the underscore is copy or not. If I go into REPL, I say let x be underscore. There you go, that's the same error. It doesn't know if this, since this is a not inferred type, how do I know if it's copy or not, right? But I think everything that's an inferable value should be copyable. Right, so we already have values. Values are either inferables or not inferables, and if they are not inferable, if they are inferable, they should always be copied. But I do this based on their type. But claim value should say that. Oh, this is a place value, yeah, result value. Should also inspect and see if this is inferable thing. And in that case, place. What do I do? Inspect. Place. Inspect value. Match value. Simple. If it's inferable. Then I return. Then I just clone it immediately, right? And I say if let's some cloned inferable, then I return the cloned inferable. Is that what I do? This stuff is probably the most complex feature so far. So underscore should always be clonable, right? Let y equal x. If I say something like let z y is equal to int32, then I know that y is a type, right? Y is x. Types are clone anyway. I mean, this is inferred at this point. It's just weird that like the values would be sometimes maybe copy and sometimes not. If I assign them from already inferred value. I mean, this specifically clones the value together, and it keeps it being inferable. Yeah. I don't know, maybe a little weird. Let's run the tests. Hash map is still not working. Why not? Oh, so now because something has been moved out. There were 2 errors in this test. Hash map line 8. Hash map line 8. Okay, I mean, this kind of makes sense, right? So here, this is where I need to change it. Hash map new should create me a hash map. Then over here, I am reassigning the map, right? So in order to insert in a map, I construct a new map basically, right? But now, since we have actual mutation, I should actually change this test. So I should insert into the map by taking a reference to it, the values, right? Like that. The hash map size also should take a reference to it. Hash map get should also take a reference. So everything should be having a reference. If I'm iterating over a map, I should probably also iterate with references. But let's do this for now. This is going to say that we inferred this as a hash map at line 4, right? So this is yeah, because hash map insert is a function that takes the hash map by value. So let's change the standard library to hash map. Let's see here. So hash map new is just making a new hash map. That makes sense. Hash map insert should take a reference to hash map. Hash map get should have a reference. Hash map size should have a reference. Hash map iteration probably will also do that. In built-in macro then expected type this got unit line 113. Oh wait, hold on. Yeah, the hash map insert does not return anything. We return unit. Right? Hash map get returns. Oh, by the way, get, if I have a reference here, this should also return an optional reference, right? Optional reference. Hash map size takes a reference returned in 32. Yeah, this one also will be a reference eventually. For now, I take by ownership. I can call this like into iter for now. Into iter. That makes more sense. So hash map iter not found. Say hash map into iter, like that. All right, so now the native expressions in the interpreter. And to change hash map insert. So hash map insert should be as a thing where the first argument is not the map type. It should be a reference to the map type, right? So we do type shape reference to the map type. That's the argument. So map is going to be reference, right? Map is a reference. So we say map mutate mutate so in this case map is a mutable value shape. We say also map is map expect map expect hash map by a mutable reference. Yeah, so I don't actually clone the values anymore. We mutate the hash map in place. Expect hash map should be like, do I copy all the methods? Like, oh yeah. Like you see, expect variant. It was taking a reference to the value and then returns the reference to the variant value, right? But sometimes I want to mutate it. I kind of want to have all three different methods, which probably should be like which probably should be generated. I could generate that code instead of writing that. I could generate all of the expect methods automatically right over here. Okay. Expect hash map. But anyway, so right now for the hash map, I need to have the mutable hash map value. Like that. And I don't return anything, by the way. The result type should be a unit type for the hash map modification. So this should be value shape unit. No parks. This is a map, a mutable reference to the hash map value. Hash map value has values, which is this behind a park. So yeah, so now I just remove the park here, I guess. And then I just say that map dot values dot insert hashable value key value. There you go. So we had a to do here of cloning. We don't clone anymore. Okay, hash map size is a thing that takes as an argument the reference to the map. To the map. Returns an int32, sure. So the map itself must be a reference. Then I say map. I guess I will mutate here, even though I don't really need to mutate. To do just inspect mutate map expect hash map question mark dot values dot length. Let size be this size. Alright, hashmap get is the thing that takes as an argument hashmap get is a thing that takes as an argument the map type as a reference. Returns the result type. Result type is new, not inferred. Wait, what? Why is it not inferred? It should be the value type. Huh? Oh, it's an optional value type. That's why. Yeah, because it should be optional. Okay, so we make it not inferred. Yeah, we make this inferable. Okay. to do use option. I just define the option in the cast code. Okay, it's fine. So it's an optional reference. That's what it should be. Yeah, there you go. To do not clone, take reference. That's what I'm going to do now, right? Or I mean, in this specific case, it's fine because I am letting the references in already. So it doesn't really do much. So the map is a reference. And a value is... yeah, what is the key? The key here... Okay, but I do have the key by value here. Which is fine for now, I guess. Okay, so say map mutate. You do inspect mutate map. Say map expect hash map. And then I say map values get. This is going to give me a reference to a value. The values are... Hold on. The values in a hash map is a hash map from the key to the value directly. But since I want to have a reference to this, this should be owned value, owned place, so I can get reference to it. So I get this. And then I say map place get ref. Right? That's what I do. Okay. So this is a value. Specifically value reference. It's supposed to be a place ref. Optional, right? So I return mismatched types. Yeah, question mark. And in this case, value ref map. So value in this case, which should be what? An owned place. Okay. So I have a reference. I store the reference. Owned place new takes value. Yeah, so we say value reference to that thing. That's what I do. Got into. Dot iter, I rename this into iter. Okay. And then I have the errors here, right? So in the iteration, so map Expect inferred, expect hash map. So in this case, I want to have the hash map by ownership, right? So here we go. We say this expect hash map nut, right? And I want to have a similar method, which is expect hash map, but takes it by ownership. And I want to have like all the 3 different variants. Yeah, I need to like generate this code instead. So this should be expect hash map. Then the values, key is a hash map value. Value is an owned place. So value should be, I should claim the value. Should claim the value here. Or what do I call it? Value take value. There you go. Take value, and then I don't need to clone it anymore, right? I'm literally taking it. Does key need to be cloned? Yeah, no, doesn't really. I do into iterator here. So I don't clone the key either. And over here I say into value. I take this by ownership. That makes sense. Alright, what is this? Hashmap insert. So yeah, in this case value is just a value, but I should say owned place. Just new owned place with this value. Okay. Let's run. This should work, I think. Variable does need to be mutable. 296 over here. Yeah, does not need to be mutable. Okay, looks like it worked. Run the tests. There were some tests that are running forever though. Wait, hashmap is still failing. Why does it fail? If this works. Oh, maybe it like, yeah, maybe it didn't, it expects now the yeah, let's see the test. What am I actually asserting there? Test. Yeah, there we go. Hashmap output. This is what I expect to be the output, but that's what I got as an output. So the thing is, since hashmap get now returns a reference to the value instead of the value itself, I return a reference to a string and not a string. I also maybe want to change the way I'm showing the references. I'm showing their IDs here, which makes not a lot of sense, but so maybe I expect a reference to world. This is a reference to string, this is a reference to string. That's what I expect there, maybe. This is what I want, right? Yeah, a reference, and I write the reference. So I think I don't do this, right? We instead say reference inspect value value.fmt f inspect tried to fmt f. No, this is a sleeve fmt display. I cannot really return the error here, and that should do it. I mean, also before writing the value, I need to say that I write the reference symbol, and then after that the value itself. All right, these tests are passing, and then we have some tests that work forever. Can I specify the like how long should the test? Oh, ensure time. Treat excess of the test execution limit as an error. Threshold values for this option can be configured via Rust test time unit, Rust test time integration, Rust test time doc test, environment variables. So all I need is to run the tests, but say that Rust test time integration is 5. That makes it 5 seconds. Has the 5 seconds passed already? I think they did not pass. Rust test time limit. Is there a way to set maximum? You can easily create a macro decoration. A timeout is this. No, that's not what I want. Was ignored. Rust test time integration and Rust test time unit ignored. Closed as not planned. The environment variables require extra CLI options in order to enable them. For example, unstable options ensure time. Okay, it's unstable. Okay, whatever. So these are the two tests, right? Context shadow and context shadow with missing context. Let's go there. Examples, context shadow. It's just like it just doesn't compile, and because it doesn't compile, it runs forever. Maybe I should look into why this runs forever first. Why does it run forever? Context shadow. Let's see. Let's see. std print 1. Is this going to be printed? It's not. Is it compiling forever? Can I say comp time std print 1? That is being printed. Okay, can I say comp time print 1 here? It does get printed. Okay, so it's when I'm evaluating the things. Let's go here. Does this be printed? It is. Does this be printed? It is. And then that, I guess, is not going to be printed. Okay, so this somewhere here. I guess show current context is the function that I cannot call for some reason. So I'm trying to call a function. Call function. When I'm calling a function, where's the await? I'm awaiting for the things to be compiled. That's what I'm doing. Yes. I'm awaiting compiled. And then I'm trying to do this in a loop. Executor advance returns a result. This is trying to tick forever, so this is trying to do all the work. This should just do that. Function is not compiled yet. Yeah, that's what I need to do. This loop never actually loops. Yes, I don't need this to be in a loop. You're right. So this is not even an async function, or is it? I mean, I'm advancing that. Wait, this was never async even. Okay. Let's just do that. So this should just say that the function is not compiled, or what? Yeah, it says function is not compiled, and the reason is the function is not compiled because it there was a compilation error. Compilation error, something return request a string, but we got a string without a reference. Context shadow, and the thing is that I'm supposed to print current string, but print now is a function that takes a reference. So I need a reference to current string. Actually, you know what? The current thing should probably be a place expression, right? Yeah. That is actually right. I mean, in any case, I'm pretty sure this is the correct thing. That's going to make it work. Context not available. This should not compile, no context available. Yes, exactly. But right now it's panicking at runtime. Because I'm not enforcing it at compile time yet, I think. Okay, so if I run tests, it's actually going to make the tests work. I should in this case try to have a mutable context, right? Test simple is failing. Why is that? Template is not a macro. Fail to evaluate source while compiling operator binary plus. Let's look at simple tests. Simple. Panicked, simple, line 11. Okay, source. Wait, but I don't know which exactly is it, right? Okay, Rust back trace is 1. A simple 17. A simple 27. This one specifically. So I'm trying to calculate 2 plus 2. And it doesn't work? Wait, really? What does it say? It says Failed to evaluate source. While compiling binary operator plus. Template is not a macro. Oh, is this like because I maybe changed something? Let's go into REPL. 2 plus 2 means 32. Template is not a macro. There we go. Why is that? So I broke the addition. Standard syntax plus operator binary plus. Standard library operator binary plus. This is a template, indeed, and not a macro. I mean, yes. Why is it trying to be a macro? While a compiling operator binary template is not a macro. Let's see, is not a macro. It's happening when I'm compiling call. Wait, what is this? It's probably an expression. Is not a macro, so this one, right? I'm trying to compile an expression, and there is a call, and they say that this is not a macro. Operator binary plus is not a macro. 2 plus 2. It's not a macro. What? Excuse me, compile call. So what is compile call? Compile call is being used when I have when I'm trying to expand macro. And this is a value. Compile call cast value values. Wait. Please activate Linux. It doesn't cost that much. Yeah, but I'm broke. I cannot afford it. Sorry. Hello, hello. Was this broken a long time ago? Could I not do a 2 plus 2 for a long time? I guess I could not. Let me try git stash and go into the REPL. Like, what, it was not working before today too, right? Two plus two. Template is not a macro. Git log. Check out 6C97. Just REPL. Two plus two. That was working back then. Okay. Which main I git log. Git bisect start Git bisect good 6C97. Git bisect bad add bisecting. 2 revisions left to test after this. Let's see where I broke it. Two plus two. Git bisect just REPL. Two plus two. Git bisect bad. Just REPL. So it's when I implemented the move semantics, actually. Potentially. 2 plus 2. No, this one is good. Git bisect good. Alright, so the first bad commit is this one, which says good progress. What did I do? My commits were too big. Good progress. Compile call. I don't even see it here. Did it change something about binary plus? Not really. So what happened is because I had the places now, right? Is copy... No, it's when I was implementing the copy. Oh, maybe previously it was being compiled as an expression and now it's as a place expression instead. Is that the difference? Git checkout main. Git stash pop. Just REPL. Yeah, that's probably the difference. Because previously, when I'm inside the REPL, I was trying to evaluate this as an owned value, but now I'm evaluating this as a place. Right? Okay, let's see. It's not a macro. So compile call. Compile call is implemented. So like, yeah, there you go. For expressions, it is working, but for place expressions, it says that it's not a macro. There you go. But it's not correct because instead I should say, okay, self new temporary value, right? Right now I cannot call a function and return a place. I always return a value from functions, right? So this means that this is a new temporary value with expression compile call cast f args span wait question mark. Yeah. I guess this is what I do, and that's going to fix it. Two plus two. There you go. 23. Nice. Nice. Cargo test. So now we should make all the tests work, I think. It was benchmarking gRPC with MPTCP. In kernel, the performance is much faster from system time, but Rust has much less memory usage compared to Go. You say but. Does it mean that Go is faster, but Rust uses less memory? MPTCP. I don't think I saw this before. Expansion to standard SSP described in the RFC. Multipath TCP. gRPC is just a protocol, right? So like it can be done in any language. Go has GC issue compared to Rust. Well, I mean, yeah, I know. Go has a GC. Some people think it's not an issue. Like, some people say Rust has a borrow checker issue compared to Go. Did my tests work? Yeah, my tests worked. Nice. Okay, there we go. All the tests work again. Nice. Okay, here's what I want to do. When I'm inside the REPL, I always say something like use std star, and I always say and also we don't have the default literal types. Because by default there is no default. I think for the sake of a REPL, I might want to like have a default so that I can use it as a calculator actually, without specifying the types every time. Let's see, command line. So we have a REPL, and I want to say something like what do I call this? Pre-run option string, like some code that I want to run. Some code that I want to run. You know? And I want to say the default value is something like a use std star, and with let's start with just use std star actually. Command. What's command? Oh, what's by default? Yeah, by default we say pre-run is none. No, I cannot do none. I want to have the default value there. Okay, let's do option. So then I don't have the default value. What is this path, by the way? Path. So I'm trying to evaluate the file. Yeah. So this is like the pre-run. Yeah, but in this case it's path. And in that case it is an embedded thing. What do I call it? Hold on. If I say something like Python has the, or like, I don't know, Bash has -c option. The commands are read from the yeah, but then it doesn't read from the std in, right? Do they have something like in Python? Program passed in as a string. It's just same /c -c as in Bash. Run library module as a script. I don't know. I'll call it pre-run for now. So that would be done after the path, I guess. So if let some pre-run is pre-run, then cast unwrap evaluate source file name pre-run. Expected type, I don't expect anything. Evaluate source. Expect build to evaluate pre-run. Contents would be pre-run. Evaluate source, I evaluate that as a value. Oh wait, I think pre-run must be a unit, right? So I expect a unit there. Hello, Nigel. Evaluate source into a value. And I expect this to be a unit. Yeah, that makes sense. Actually, pre-run is always existing, right? Let's just say that pre-run is pre-run unwrap or, and this is where I do the default. It's going to be use std star. Strapple. So now I say int32 and it exists already, right? I don't need to type the use standard library. For the sake of REPL, I like this. And also, like I said, we want the default number types. So I have the default number types here, and I guess let's just say that this is what I need. The default number type should be based on the presence of a dot in the literal. So we default to either int32 or float64. So in the standard library, I want to define this. So default number type is this, right? And then I will say that. So I need to name this something though. At What do I call this? That it contains. Contains also is not it. Contains is over there. Yeah, that's fine. What do I call this? So like I want to have predefined options that I would be able to choose from. Default number type based on dot. Let's just have this for now, and I will have it here with the default number type based on dot. Okay, so 123 is going to be an int32 now, and 123.0 is going to be a float. Right? 1 divided by 2 is going to be 0. 1 divided by 2 is going to be a thing. While compiling this, expected a float got int. Wait, what? Is it because over here I need a dot? That was supposed to be inferred though. I think I know why, actually. I actually looked at this before. I don't do this properly right now. Let's fix it. When I say default number type, right, in the compiler over here. Yeah, there we go. So when I'm compiling a number, I'm trying to invoke this function at compile time, and then I say that the type of the number is this, but this should be a default. That should not be the actual type. That's the issue here. So I need to say type expect type. All. Wait, what if this? Oh, wait, what? What's the default one? The default one is returning new not inferred type? I guess. Okay, anyway, so I do here type new not inferred with default. And the default is going to be the expected type. Question mark has incompatible. What do you mean incompatible? Expecting a new type shape? Oh, so the default here must be that. Yeah. Okay. That is weird. I mean, not weird. But I guess we say, that type is type expect type. Okay, if type inferred. Yeah, I guess I just match type inferred. If it's okay inferred, then I'm going to say that it's not inferred with default being the inferred thing. If it's an error, I think I just returned this type as is. So this allows me to return from this context the new not inferable thing, and then I can assign it in some other place. That would be weird. I think this should actually be the function that returns. So like you see how this function returns, this takes a string, which is the raw representation of the number, and then it returns a type, right? But this should return optional type instead. So if I want this to have a no default, then I should return like a new not inferred thing, an underscore, which is a little weird, I think. Maybe to should return option type, I think. But anyway, this should work, right? Inferred is a method. Two plus 2 is 4. 2 plus 2.0. Literal number type could not be inferred. Okay, actually, this does make sense. This does make sense. It was nice sleeping with you, Kuvi, because I sleep lurky since the beginning of the stream. Nice. So in this case, this doesn't compile because this defaults to an int32 and this defaults to a float. So which one should it be, right? It's like it must be the same thing. The error message could be better here, saying that it could be an int32 based on this, in float 64 based on that. Or we could just specify the type here and then it works. Yeah. Okay. That's good. Run the tests again in case that broke something, but it shouldn't. You have shitty Rust another try yesterday. You gave Rust another try yesterday. All right, what did you try to do? Abomination. Called the Rust compiler. What did you try to do? Are you making your language still? Okay, what should I do now? This thing works. We can calculate 2 plus 2. Simple TCP server with Tokyo. All right, sounds simple. So you had a skill issue. Is that what you're saying? Pum, 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 pum. Maybe I should work. Maybe I should try actually writing something in the language. What would I write? Well, I want eventually to write a game, and I want eventually to write A bot. I guess bot is easier. Maybe I should work on that. REPL pre-run. Um, so can we do something simple? Like let's imagine that I'm writing a bot. A Sokoban game, of course, no. Yeah, of course, no. Rusty complaining about lifetimes. Yeah, skill issue. It's fine. You get you start understanding it at some point. You can show the code if you want some help. So how does a Twitch bot work? I want to get the you know, for how long this socket lives, since you're smarter than Rust C. Does your socket live on this on the stack? Because lifetimes is only about the stack. It has a static lifetime on the stack. Yes, I guess it should be doable with lifetimes then. But otherwise, you could always put it behind like an arc mutex. You invented a new approach. All right, can you show it? So what if I want to do something simple, you know? So I say handle chat command. So handle chat is going to be a function that takes a string. By the way, how about first? Pretty sure that my guess a number is not being tested. Guess a number. It doesn't even work. Ah, lol. Oh, because I cannot do the input. That's right. You're sending owls into space and they arrive at the PC. I can read their data. Full chat. Function which takes a string and then I don't know. Here. Am I ready for something like that? I don't know. If it's just text commands, it should be simple, right? So like if it starts with something, right? Exclamation mark. There should be a rotating version of this. When someone yawns, I have an urge to put my finger in their mouth. Did I just do that? If, let me see. Just run examples TTV. Handle chat exclamation mark hello Pigorly. A reference to a string. Option string optional reply. We can just do something very simple like that, where I give this an optional reply. If handle chat is some reply, and print reply. Okay. Some Pigorly. Okay, that works. Maybe I say something like commands is so is function. I think I do something like this. Arguments is going to be like a list of strings. Now what to do? So in this case specifically, I don't really care about the arguments. I want to find the command. I want to split white space as for for I don't know, argument in split white space as pbg arg. This doesn't work right now. I need to specify specifically that this is a character. No, not a character. String. Oh wait, what exactly? Call expression at 15. Handle chat was function as well. Split white space is not found. There you go. What is split white space? Yeah, split white space in standard library? I don't think so, right? I was doing this for the advent of code already, though. Split white space. Function from string into unit with context. Is that what I call it right now? String. Make unit, not a place expression. Where? Line number 9. 44, 46. This is not a place expression. Okay. Sure. Not a place expression. Make unit. Yeah, if this is that, then it's going to be compiled place expression new temporary expression unit data span itself. Did you know that yawning is contagious? Reading or hearing about yawning can trigger yawns. That shows we are more likely to catch yawns from close friends and family, highlighting a link between contagious yawning and empathy. How many times did you yawn while reading this? 0 times. What does that mean? Function not compiled. Expected type unit got this, yeah. So I go back here. This should return none. It means you hate Veldak. Got it. Alright, so what is split white space? I do have the way to iterate over the characters. I think in the standard library, that's the only thing, right? Characters. Yeah, characters, a generator and letter characters from a string. This, by the way, should probably take the string by reference. I think. Characters should take the string by reference. And return the... and it's generator of characters. So value should be expected to be a reference. Right? Yeah, there we go. To do use ref. Now we actually use ref. This is a place. So value is a reference. I kind of need to, like right now, all I do is inspect, which takes the closure inside, which is very limiting. Instead, I need to like borrow it and have like a runtime borrowing of places here, right? So it should contain instead, like, I guess I should have methods like read and write, which lock the thing. Yeah, it should be like more like a read write lock probably. The places. Okay, but for now I can say inspect value expect string wrap owned it's like a value to do not clone. I'm just going to clone it for now, it's fine. Lol shit fuck, wishlist just got update. 700 wishlists came yesterday. Nice. That's like from the video, you think? Of the dude? Value clone expected for expect string to owned. This is cloning twice. Yeah. That's fine though. Just REPL for C and characters hello world dbgc. Yeah, there we go, that works. Split white space. How do you split white space again? So we go for this in characters and so I don't have the ability to take substrings, so instead I just construct the new strings, which is fine. That for now. Okay, so I think I maintain something like current is none. And then I say that if current is none, then current is some empty string. And then I say let some ref current is current. And then I say I'm gonna say current is current. Do I have something? The standard library. Push character, yeah, sure. Push character current, and see. That's what I do. So current is an optional string, right? And then I say finish is what's loop context? This should be called something like yielding, maybe, with yielding string. It means that this is a generator function. So it requires to be called from within a loop. So I call it a loop context for now, but that's not a very good name. Yes. Because this should yield. Actually, do I have yield? Yeah, I do have yield. That's literally what it's going to be. It's going to, like, over here, it's going to yield yield current, but only if current is some current. Only then I do that, right? This takes it by ownership. I need to also say that current is none. Yeah, I think that's it. Current. Oh yeah, that's right. Current is a keyword right now, which makes it a little bit annoying. Maybe I should change the keyword. What should I change the current keyword to? Current is not a good keyword to have, I think. But I don't know. I'm gonna finish parsing if expected a value. Yeah, because over here also. There you go. Your lat pattern match opposite to Rust. If core is some core is the same as if lat. Yeah, it's since this is literally the if lat. There was a proposal for Rust to have this syntax too. I don't know. I think I like the is more than with lat. And you can also like chain it. I'm not sure if it works with chaining right now for me, but yeah. Line 26. So what is wrong here? I think this must be in parentheses. Yep, there you go. Okay, function is not compiled yet. Pattern place expression. Tyler 1827. Dereference. The reference must be a place expression. Wait, hold on. Did I do reference in the thing? Oh, yes, I did. Okay, I now remember. There was one thing that I did not do correctly. Over here, see, I have an assignment to the dereferencing, right? So right now, the way I'm doing this is the thing on the left of the assignment must still be a pattern, but using existing bindings. But this means that dereferencing doesn't really work. The way this works in Rust is the thing on the left of the assignment operator, it must be a place. I can do the same thing, but then it means that I cannot wait, how does this work actually in Rust? How does this work in Rust? Let A and let B. A and B is 1 and 2. How does this work? Because this compiles, right? Rust reference expressions. Place expressions and value expressions. Assignment. The following context are place expression context, the left operand of the compound assignment expression. Compound assignment expression is expression that. Oh, this is plus equal. This is like when it modifies. That's what compound, which is combines with assignment. So on the left there is always a place. What about a normal assignment? So on the normal assignment on the left side is not a place then. There's something different there. It's like a mix between a pattern and a place. Right? Can I search for assignment? Assignment expressions. Expression is expression. An assignment expression moves a value into a specified place. An assignment expression consists of mutable assignee expression. Okay, so assignee expression. Expressions are divided into two main categories, place expressions and value expression. There is also a third binary category called assignee expression. Okay, so that's what I don't have right now. An assignee expression is an expression that appears on the left side of the assignment operator. Explicitly, the assignee expressions are place expressions, underscores, tuples of assignee expressions, slices of assignee expressions, tuples, structs of assignee expressions, structs, and unit structs. Arbitrary parenthesization is permitted inside assignee expressions. So it okay, yeah, I mean that makes sense. It's like special though. I can make it special too, just like that. But this also means if I have well, I mean tuple of assignee expressions work, yeah. Hmm. I mean, yeah, I think I will need to implement it just like in Rust as a third kind of expression. Right, not yet though. For now, I think I will just allow this to be a place expression. It means that I will not be able to assign to tuples, though, like that. But yeah, I should definitely allow at least a place expression on the left side there. So macro assign is doing the pattern, right? But this, let's call it assignee. Yeah, so I previously had a hack where the pattern was using existing bindings. What the hell are you doing, lad? Some ref core on line 26, what if core is none? Right now it just panics. I can assign to this. Yeah. In Rusty that would require a let else. Um but I think this should be like, because I don't have the exhaustiveness checks right now in my patterns. You can have a match which doesn't have all the branches that are possible. So I'm just panicking if it doesn't assign. But I mean, I kind of want to be able to write that sometimes. Maybe I will just call it like a let assert or something. Pile mic, sorry. I don't know if this will ever be fixed. Okay, so we have assignee, and assignee is going to be actually a place expression. Use existing bindings is something that I no longer need at all. Add assignee expressions this stream. Okay, sure. Sure, let's add assignee expressions. So we have now, so right now we have two types of expressions. Place expressions and normal expressions. And now we will have another one. Fine. Enum assignee expression. It's kind of like a mix between a place expression and a pattern, right? Yeah. So here's a place expression. And here's a pattern. I need to have a mix of those. Right? So what do we have? We have a placeholder. We have unit. We have binding. We have tuple. Tuple of assignee expressions. Variant. A variant should not. I don't know. It probably should not happen, yeah. Field access should not happen. I mean, that is like a place expression, right? Temporary reference, yeah. So like just place, place expression, like that. Placeholder is just the like the any pattern. Use existing bindings is going to be removed completely. So expression assign is taking an assignee expression. Why is value here a place expression? That's also weird. When I assign, I always take the value, or do I not always do that? Well, actually, let me test what it does in Rust. If I have A is foo and B is foo, and I have struct foo, right? If I say let C, let D, all of those are of type foo, right? You know, everything is foo. If I say C and D is equal to A and B, and then I say like derive debug dbg a, this is going to not compile because it moved out, right? But if I say underscore here, this also moves it. Okay. Okay, yeah, that makes sense. But what if I have a tuple? And a tuple is A and 1, 2, 3, you know? Because in this case, D is 1, 2, 3, which is a copy type. Right? Does it copy this? It still is moving it, right? So moves occurs because I move it here. Yeah, okay. I mean, yeah, that makes sense. I mean, what I'm trying to see here, if I can debug a tuple here. I can debug a tuple. All right. So yeah, this is actually still is just like a place. So I only try to claim this value, which copies it instead of moving it, and this value stands in place, and this value stands in place. Tuple is still usable. All right, makes sense. We'll do the same thing. This would be not a pattern match anymore. This says assigned to existing bindings, which makes no sense anymore at all. It's only been used here. We remove it. We instead say just assign. Assignee. function assign self assignee is assignee expression place ref. I don't know, can this actually fail? Maybe. No. So I match assignee. If it's a placeholder, then I just do nothing. If it's a unit, then I also just do nothing. If it's a binding, then I assign to that binding. So what? I mutate? I don't actually mutate. I say assign. Yeah, assign the value. If this is a binding, then I claim the value from the place, right? So place claim value. Self question mark. There you go. I don't care about the data. All right. If this is a place expression, let's call this value. Let's see if it's a place, and I say place dot assign. Well, I mean, technically bindings are also just place expressions, right? So, yeah. I don't even need this. Anyway, this place is a place expression, so I need to say self-evaluate the place, right? Which means that it is also async. So that's my place, and I say place assign value claim. Right? Assigning never fails. That makes sense. So binding, you say, I think I should not have it. Should I even have a unit? It's like, I mean, it's same as tuple, so maybe, yeah. Data stream, why do you have this kind of assigning expression instead of an interpreter loop? Aren't these just syntax sugar? Are these just syntax sugar? Let me think. It should be eliminated before you get to the yeah, maybe, hold on, maybe you're right. Let me think about this. Should this be just a syntax thing? I mean, my intermediate representation is pretty high level, right? So I don't really mind it too much. But what is this syntax sugar too? Does this means that this is like saying that underscore is equal to tuple 0 and d is equal to tuple 1, right? That's what this is about. Yep. That's right. Then before you get to AST, not to AST, to like AST is including the assignee expressions for sure. But I guess like the compiled intermediate representation doesn't necessarily need it. Maybe. Well, first of all, I cannot really do this yet, .0, for the tuple fields. So the only way for me to do it is actually like supporting that right now. But if I implement the .0 for tuples, that would work. If I I mean for structs with names, that would work already though. I mean, I think it's not like too bad. Like I said, my intermediate representation is really high level. I'm not trying to like compile it down to something like as low level as possible. This also means that when I write the transpiler, actually, I can keep the code. Like if I transpile my code to Rust, I can keep this, right? But when I transpile to something that doesn't support assignee expressions on the left side, it would need to be written like this anyway, right? How does my AST look like? You have parse tree AST from LLVM. I don't have the LLVM. I mean, what I call AST, I guess, is more like just the parse tree, what you say, or it's like what, the concrete syntax tree. Right now I have basically the source code into the tokens, which like Lexer produces the tokens. Then this, I call this AST, but it's, I guess, just the concrete syntax tree, right? Parse tree, whatever. Then I convert this to intermediate representation, which is my own intermediate representation, which is not LLVM. It is high level intermediate representation. Eventually, this would be like done. This could be done to be convertible to LLVM intermediate representation, right? Right now, though, instead of this, I just interpret this directly. Right? So this is my compilation step. Basic compilation right now for me is converting AST into high-level intermediate representation. This includes like it's basically it's kind of similar to AST plus type information, kind of. So like the type inference is already running here. So you don't really call it AST anymore, right? So like, yeah, you say AST, but AST you usually don't. It means that you don't like do like type checking there, right? This is supposed to have like type checking and borrow checking already ran over it, I think. I'm not sure about the borrow checker yet. Borrow checker might require a completely separate step eventually. We do type inference and type checking on AST. But AST is just a syntax tree. So I don't know if it's correct to call it AST. What's the language that you work on? Am I naming things incorrectly? Or are you naming things incorrectly? I don't know. I might be naming things incorrectly, yeah. Like, what's the difference between AST and intimate representation anyway? AST versus intimate representation. What is AST? Data structure used to represent the structure of a problem or common snippet. I mean, intermediate representation is the same thing. I mean, AST is just one of the intermediate representations, right? Syntax is abstract in the sense that it doesn't represent every detail appearing in the real syntax, but rather just the structural and content-related details. For example, grouping parentheses are implicit. Down. Syntax tree. No, syntax tree has all the syntax shenanigans. The nodes contain all the tokens. And so on. That can appear in syntax, and AST is abstract without that. It does contain all the tokens that can appear. But it's still like what I'm making is no longer a syntax tree. I still think it's not a syntax tree anymore. No? Once I do the type inference. I don't know. I didn't read the books. I have no idea what people call things. But my AST is definitely not the AST. I'm also like not storing everything that like appears in the input in my AST, but I should add like the white space so that I can reconstruct the original code with my AST, which would make it at CST instead. Yeah, if you have function called node, function call opening brace name arg closing brace. Whereas in AST you'd have function call name arg. Yeah, but also here's the thing. I don't know if about your language. My language has macros, right? So I don't like when we talk about the AST in Rust, you say something like you know, like this derive macro, right? You see this derive macro here on this thing. This runs code at compile time and generates new code, right? So when I like my compilation process and the thing that I'm calling the intermediate the intermediate representation is something that already has expanded the macros. Do you, like, for example, in your AST store the unexpanded macros, or is your AST already has the macros expanded? I don't know, like if you take a look at the syncrate, for example, this I mean they call it the syntax tree. They don't call it the abstract syntax tree for sure. We don't have macros per se, but we do some expansions on CST, and AST already has all that expanded. Okay. All right. I mean, I don't know. Like I said, AST is basically one of the intermediate representations. Maybe I should just call it AST, but I'm calling AST right now the syntax tree, which I guess is wrong indeed. Anyway. So in the case of the AST, do you have the assigning expressions in the AST? Or like when you go from yeah, we can get rid of this, since this is just syntax sugar. But also I guess other things also could be removed from here because they are just syntax sugar. For example, the is expression is just syntax sugar for a match expression, right? Or I guess an if also is a syntax sugar for a match. You can pattern match on a boolean instead, right? Do I want to get rid of it then? I don't know. So what's your language? Are you working on some big language? You say we. So you like work for a company that's making a language? Is it your job to make a language? Anyway, if I have a tuple of assigning expressions, I think I'm going to keep this for now. So value, I need to inspect the value. Value must be a tuple. Expecting for graph value. You don't have much transformation in ST, doesn't matter, but if you have a lot of features that are syntactical, it will help you in the long run. So I mean, syntactical features are done with macros. So technically, like I'm trying to have like as little things as possible there. For example, my loops are already like not in my intermediate representation, but they are done through macros instead. So like the syntax for the loops is defined something like this, and then it basically rewrites itself into this, and this is already defined in the language itself through the macro system, like in Lisp. You know, you can have custom syntax, and it's working with a macro system similar to Lisp. For the assigning expressions, I kind of could. Yeah, I mean, I don't know. It doesn't matter too much. Like I said, it will help me to, like, since this is more high level, basically. I can only, like, the only, like, plus of this is that when I transpile the code to, like, a different language, I can keep it be high level. But since my loops, for example, are a syntactic sugar, and I compile it down to something lower level, doing that with loops would be more difficult. It's a query language for analytics company is not big. Do you want to dox yourself? All right. Nice. Okay, so I have a tuple of assigning expressions. And I have over here a value shape. I say value expect tuple. So this is a tuple reference to a tuple value. I have this as a reference. Well, I mean, tuple value is just, it has places inside, right? Anyway. Yeah, so it says, what's a tuple? Tuple value, tuple owned place. Yeah, there we go. Expect tuple question mark. Dot zero dot I mean, I should just zip this thing, right? Yeah, I should say tuple.zip with another tuple. And I go over the values. For value in for assign for field assignee and field value. That is it an array? Hold on, what? Mismatch types. Tuple. This is an iterator with items of type tuple. Wait, hold on, zip. Result. Yeah, because this is a result. Question mark. Cannot move out of tuple which is behind a reference. Tuple as ref. Cannot move out of a shared reference. This should be a reference. Are you losing the mask of sanity and thinking Rust tuples and cast tuples at the same time? They're basically the same. I mean, maybe I should not call them tuples though. Maybe I should call them something else, because we have both named and unnamed fields. I don't know what to call it. I could just call it a struct, right? Zero dot as ref. Sure. So now I have an optional string and this. Okay, I don't care about the names of field name, and then we have field assignee and field value. There you go. So we have field assignee, another assignee expression, and this is an owned place inside the tuple. So we say inside of here, self assign field assignee and field value get ref. Waiting here will not work. Let value be value expect tuple 0 as a ref app place get ref. Okay. Okay, so value in this case is a tuple of place references. Yep. So I just zip with the value like that. Call them tables like Lua. Yeah, there's also like records, tables. Well, I mean, wait, hold on. So Lua also has tables, and their tables also have named and unnamed fields, kind of, right? Wait, can you have in Lua playground? Can you have in Lua a table with both named and unnamed things? I think you can, right? Can you print? This just prints table. Lua print wrapper. Lua equivalent of Python wrapper. Would be colon Q string format. Can I do that? String format %Q. That. Does that work? Value has no literal form. How do you do? Lua print table. How to dump a table to console? This is literally how you do it? Really? Okay, let's have a function dump. Okay, print dump. Does that work? There you go. So can I say hello world? There you go. Well, I mean, it's just like the keys are this, but can you mix both of those? Can you say like hello is what? Is that how you write it in Lua? Yes, that's how you write it. Okay, yeah, there you go. So I've done the same thing as Lua did. What if you say like 2 equal 2? You cannot have this, right? This must be a string. No, this must be like an identifier. Yeah, so or can you maybe say like that, because that's how they were printing it. Yeah, there you go. So 0 is 2. Okay, can I say 2 is 2? What is going to happen? It just, okay. So in this case, it just removes this. It doesn't exist anymore. Okay, got it. What does Cas do in this case? Well, I mean, I only allow the identifiers here. I don't have this syntax, which, I mean, I think I should have this syntax, though. This is a good syntax. I like this. What I don't like is that they start counting with 1 instead of with 0, though. Question mark? Is that what I do? Triple question mark? Image types. If I comment this out. This is an iterator of type tuple. Oh, it's because, oh, okay, no, that makes sense, because zipping can fail. Yes, that's what I do. Zipping can fail, sure. That's what I do. Triple question mark, nice. Assign Field assignee, field value. Oh wait, there you go. You might meant to return. There you go. Recursion in async requires boxing. So we assign and then we say boxed and then we await. Gonna check whether the hidden type of opaque type satisfies auto traits. Boxed local. That works. Okay. Okay, what is this? Initialization of the assignee here. So I should have same as with other things. For assignee expressions, I should be able to get the data. So I have only those 4 things. Data. Okay, so this over here now is not a place expression. This is an assignee expression. And we need to make it compilable. Compilable. Let's copy paste this. Compilable for assignee expression, compiled type, assignee expression, compiled type, assignee expression. Okay. From compiled, this should be assignee. Cased AST simple expression compile. This is compiling a single token. All right. Yeah, so some of these are expressions, but binding is a place. That makes sense. I kind of do the same thing, and then I do the into. So I need to have a from. Maybe we should have a try into. And I will have something like impl try from. Simple expression or assignee expression. Like if I have a place expression, then I can do that. Data is going to be the same data. as the place expression itself. If I have an expression though, which is not a place expression, because I cannot assign to a number, I should rename this into, instead of simple expression, this is like a single token expression, maybe. That's a better name, I think. All right. So like I cannot have a number or anything. I think this should fail. Saying expected assignee expression. No variant. Compiled assignee expression. Okay. Compile. So if it's not as simple, if it's a syntax definition, that should be fail expected assignee expression. All right, and over here we say expand macros. Yo, Togglebit. Hello. Welcome, guys. Thank you for the raid. How's your game engine doing? How's the progress? All right. I don't know if you've seen this project of mine or not yet, but I am making my own programming language here. It's been a while. It's still very raw. We have some things working. It is let me just stash here. It's supposed to be a language kind of similar to Rust, but with like the effect system. If you know what that is. I recently implemented the ownership semantics. I don't have the borrow checker, so it's like a runtime borrow checked. Like this, for example, makes x be a string, and if I move x into y like this, just like in Rust, then y is a string, but x has been moved out. This has been checked at runtime only, though, for now. That's like the latest feature that I added, the movement semantics, and right now I'm implementing the assignee expressions, like in Rust. In Rust, there is 3 types of expressions. There is there's value expressions, or like, what do you call them? Just normal expressions. There's place expressions, and then there is assignee expressions, which is a dedicated type for the left side of the assignment operation. Like this. I have to go and cook. Yeah. Thank you for the raid again. Have a nice rest. But for any raiders that are interested in this, we also have I also made the website for the language, even though it's a little bit outdated. I don't think I was talking about the ownership here at all. But you can see about the other features of the language here. One of the biggest features, I guess, is similar to Zig. I support compile time execution of code. I don't really like compile things down to machine code. I only have the interpreter currently, but it is planned to be only one of the targets. The interpreter is needed to run compile time though, to run code at compile time. And yeah, the actual compiler is going to come eventually. My current plan is to first transpile to JavaScript though, instead of doing native compilation. After I'm happy enough with the progress on the interpreter. But we do have like type inference, for example, and have a bunch of things. I don't know. Maybe I should make guess a number to work. I had this example, which is a game of guessing a number. It's currently broken though. I should fix it. Anyway, let me go back to implementing assign expressions. Whoops. Conflict. Oh no. Did I try stashing twice and it broke everything? Or is it fine? No diagnostics found. Hold on. Let me restart. Yeah. Oh shit, this is bad. Why did I did this stash twice? Can I undo this stash? No, because I didn't commit anything, right? Discard this. And what is that? Stashed changes. Or was it? AST. Wait, did I change something about the AST? I did not. I didn't change anything here, did I? So this is from the stash. Let me just remove this. I'm pretty sure I did not make any changes there. It's better to commit to a temporary branch instead of doing stashing. In that case, no. Expected 4 arguments, found 3. Nice. Read expression. Pretty sure I did not change the AST at all. Hold on. I'm just going to discard this file completely. Okay, and then I Rust analyzer restart. Okay. Yeah, that's it. So I'm compiling an assigning expression. If we have a call, then I should not be able to assign to the result of a call. So this should just fail saying expected assignee expression. Spend macros. There's only this problem with a tuple. Maybe. Compile into. Compiled type assignee expression. Compiled assignee. Like that. Alright, macro merge. Assignee. What assignee? Macro variant. Scope. This is just an expression inside parentheses. I kind of wanted to do here to do probably need to enter scope in all cases. Make unit. Sign expression. Do I have a sign expression unit? I do. So there you go. Data span dot init self. So I need to have the initialization of the type info there too. Let's have it here. Implement sign expression span. Info base expression. That's quieter than before the raid. Chat is just not understanding anything. You think I understand anything? I'm not understanding anything. I would be quiet if I saw this shit too. All right, let's see what I do here. So this over here is the initialization of the type inference. So I have this should result assignee expression. Right, so we have expression data. Expression data has the span information and the type information. So since this is a placeholder, this can be any not inferred type. You didn't know about assigning expressions, but the timing is great. I will use them to distinguish expressions in your toy language too. Okay. Nice. Expected span found. Oh, because I cannot no longer do self. Okay, this is also kind of annoying to repeat the name. Okay, fine. Because if I use self, it uses the same generic argument. Okay, if I have a unit, data, expression data, type is can I have a pointer redeem to change the size of the activation watermark? Do you want it bigger or smaller? Bigger? I don't know. I'm kind of like writing the code right on top of it already. I don't know. Maybe it's already too much. No, I don't think it should be very disruptive. It's not enough in the way. Yeah, do you want it to be in the way? Type shape to owned. Hold on. What do I do here? Unit. Yeah, so the type of the unit is the unit. That makes sense. Span. All right. Now, if I have a place expression in place of an assign expression, not placeholder, place. Then I have the data, the expression data, where the type of this is the same type as the place type. Place data type clone. That's it. A little more and we will understand it. I don't want that. Don't worry, I'm already... I think you shouldn't need to worry about understanding my code. I don't know. How is Nigel doing? Nigel, you were trying to add the quantifiers. You needed to figure out how my code works to do a pull request, right? How is it working? Is it understandable? Assign expression tuple. Expression data span. Okay, so what's the type of the tuple assigning expression? It's a tuple type, right? It requires more attention than you would normally require. So tuple so I need a tuple of types here, right? So I do tuple dot as ref map field dot data type clone. There we go. That's all I need, I think. Like that. This probably doesn't need to be async. Impressive how quickly you write such large logic, but it's difficult to follow. Yeah, I mean, if I was focusing on making it easier to follow, I would definitely work slower. Like, I think the plan would be to actually rewrite parts of this from scratch, or, I don't know, refactor them eventually. Right now I'm focused on having a prototype, so I'm trying to move quickly rather than make the code nice, you know? Aren't you gonna rewrite in cast anyway? Yeah, I mean, we will rewrite it in cast anyway at some point, but I don't think it's going to be really very soon. I'm not sure if there's going to be another rewrite in Rust before rewriting it in cast. Okay, so I have a tuple here. Expression compiled assigning expression. Compiled assigning expression. Assigning expression tuple. Devon starts his project by putting warm missing docs in the project root. So he's doing documentation driven development. DDD, right? It's missing documentation for everything, not only for types, also for methods. For anything that is public, I guess, when you're making a library. Expect assignee expression. Expect assignee expression turns assignee expression. There you go. What is this? A placeholder. If I'm compiling a placeholder, then I say placeholder. Type compiled assign expression not EU data not E. And this says, so this says assign, right? So assign. This is just async and that's it, right? So we just await. Everything should work now. That was the last warning. If we don't have warnings, future cannot be sent between the threads safely. Oh my god. Hold on. Hold on. So because function assign, actually this should actually be a boxed, not a boxed local. But if I do a boxed, then it's going to say, cannot check whether the hidden type of the opaque type satisfied auto traits. That's why we're going to redo this into function assign, which returns a box future. Like that. And then I say let impl be async move. And then I just return impl boxed. That's how I do it. Box future. Kek loop. Hello, hello. Lifetime may not live long enough. All right, let me just make the lifetimes live long enough. Oh, this is immutable. That's why. Can I even annotate this properly? Not sure. Actually, this is all done. There we go. That's how you solve the lifetimes. Easy. Alright, so if this compiles, this is going to work. Let's see. Let's see. We have assignee expressions now. On the left side of the equal mark. So if I say underscore equals 1, 2, 3, this is going to say field pattern was not expected. Nice. Because I renamed assignee to pattern to assignee in the standard syntax. Assign. This should be named assignee now. There we go. Underscore is 1, 2, 3. There you go. This works, right? So if I say let tuple be 1, 2, 3 and 4, 5, 6, right? So my tuple is this. If it compiles, it runs for a bit. Hello, Raymarch. So now I should be able to do. Now I should be able to do A and B. Well, I mean, for that to work, I need like existing things, right? So like A is equal to underscore. Yeah, I should be able to like have the binding without a value like this. This doesn't work right now. I should make this too, to create a place without a value. But for now, I can, I guess, do this. Let A is underscore and B is underscore. And I should be able to do A and B is equal to the tuple. So then A is equal to 1, 2, 3 and B is equal to 4, 5, 6. There you go. There you go. Tuple now has the string moved out, which makes sense, right? I can also say A and underscore equal to the tuple, right? This will still work. If I say underscore B, this is not going to work because it's already been moved out, right? But I can still take the first value from there. Okay, this should work recursively too. So I think I implemented this. We have the assignee expressions now, Raymarch. We have now in the language we have actually 4 kinds of things. So I have patterns, expressions, and expressions are of 3 types. There is well, I guess there are kind of separate things anyway. So like we have patterns, expressions, place expressions, and assignee expressions now. What's a place expression? It's an L value. You're a C++ guy, right? It's L value versus R value. Yeah. Do you have like an alternative of the assignee expression in C++? C++ assignee expression. I don't know. Like if you say assignment operator, what is the left side of the assignment operator? What is this? What can this be? Or is this just a place expression in C++? I mean, I guess so. This is just an L value, right? Or can this be something more complex than an L value? Like in your date, it was an L value, yeah. But like the difference is the thank you for the follow, everyone who followed. So in Rust, this is not just an L value. There's a dedicated assignee expression because I can have over here, for example, a tuple of 2 L values, right? And then it will do the unpacking automatically. That's what the example I was showing here, right? This over here is not just an L value because it looks like I'm constructing a new tuple, but it's not, right? It's doing some destructuring at the same time. So it's a mix of a pattern match that works. Yeah, that works in Rust too. Actually, in my language, I have the different priorities, so I can do this. I don't even need parentheses there anymore. I can do that. I can literally say A and B is equal to 1, 2, 3, and 4, 5, 6. Is this Python now? I mean, kind of. That's, I mean, we want it to be easily usable. It's Python, but with types that are actually checked, right? At least for the most part. There's a lot of things that are missing. We missed the borrow checker. I missed the checking of the contexts, the effect system. It's Python by the good. Python cannot do named fields though. Yeah, Python doesn't have the I mean oh, Python cannot do like the destructuring here. Actually, I'm not sure. Python, they added some Python pattern matching. I know that they added it. I'm not sure how it works. Structural pattern matching. Let's look at this. This is a tutorial, right? So you can say over here, for example, right, you can do destructuring into tuples. You can do destructuring into lists. Too, right? And actually, like this is an iterable, right? It's not even a list, I think. It works with some like runtime logic. You can also have matches. You can have cases. Matching specific values. Matching multiple values. Adding a wildcard. Composing patterns. Can you do this on like in not pattern matching though? In not like match expression? I mean, I think you can, because like over here they have an example where it's in place of the on the left side, right? You may be tempted to do the following. The problem with that line of code is that it's missing something. What if the user types more or fewer than 2 words? Yeah, so it just panics. Composing patterns. To go one step back from the examples, understand how the patterns you have been using are built. Patterns can be nested within each other and can be doing that implicitly in the code above. There are some simple patterns, which are literal patterns, wildcard pattern, and capture patterns, standalone names. Okay. And then you have a tuple. Or pattern. Okay. Capturing matched subpatterns. As direction. Okay. Adding conditions to pattern. Adding a UI. Matching objects. So you can like case key press. Like, what does this do? This is a custom thing. You never noticed the nuance, so it doesn't work with refutable patterns on the left. Wait, does that not work? Let me see. Assignment else is not allowed. Yes. Yes, you're right. So what do you think, like, how do you think this should work? I was also like thinking of another example that is not possible, right? Like, you know, you can say let AB is 1 2. You can say AB is 1 2, right? But you cannot say A and let B is 1 2. You know, that's another thing. You don't know a use for it. Um, um, I mean, like it's like a syntactic sugar. But I mean, this whole thing is the syntactic sugar, right? Because you could instead say x is 3 and some y is some 4. Like, this entire thing is syntactic sugar. Like, someone said in chat earlier that maybe I should not even have the assigned expression in my AST at all, and we should just like expand it, since this is just syntax sugar anyway. Actually, like binding in weird places. So if I wanted this to work, I'm pretty sure, like, I had the idea of where I could make this work. So on the left side of the assignment operator, we actually have I guess we do have, like, if we have the assigning expression, that is already works. So in a part of the assigning expression could be a let pattern, basically. I could literally allow this. You know, what if in like one like, yeah, look at this. If I do assigning expression, so we can have a place expression, right, as an assignee, but I also can say let, right, and then we would have a pattern here, and then we can like mix and match those together. You know, I can make this work. It's not that difficult, actually. Still don't fully comprehend what is so special about assignments that every language has to do that so extra. Well, I mean, there is a special thing about it, right? Like this is not just an expression. If you see this as an expression, then it looks like I'm taking the value of A, right? And I'm constructing a tuple where the first value is the value of A. But that's not actually true. But at the same time, maybe it is true. You construct the tuple to have it assigned to. Yes, I mean, yeah, I kind of like, yeah, I had this. So like, what if patterns were treated as values, right? What's the bang after the panic do? This is just a macro. It's this is a macro in Rust. Actually need to end soon. It would have to move into the type system. TR would be one of the types of the assignment expression, except Here's the thing that doesn't work in Rust. So this thing, I can make it work. This thing is relatively easy to make work, actually. I can make it work right now. But one thing that doesn't work is if you say... I literally had this code before, right? If I just Control Z here. Let's take a look at this. So I have a struct foo, which is not copy type, right? So what I want is I want to say C and D is equal to A and B. And then I try to debug A. This doesn't work. This doesn't work because I moved the value A. Specifically in this case, I moved A to C, right? Now, what if I don't do that? This is still being moved over here, even although I don't like actually assign it to anything. You know what I mean? I feel like this could work. Because over here, when I construct this value, it doesn't actually construct the tuple, and it doesn't actually take the values yet. When I make a tuple. Maybe, somehow. You know? Similar to how, like, this is also not taking the value of D, right? If this and that is literally the same thing, if those are both just expressions, somehow. The special caseness gives me the ick. What is a special caseness? Or you mean like the current state of things, where you have like dedicated place expression, dedicated assignee expressions, and that's what gives you the ick? So yeah, I mean, yeah, if I could get rid of the special caseness, that would be nice. If everything was an expression, that would be really nice. And so, like, if a pattern was also an expression, right? Like, if you inside a match, how is this different from any other expression? This over here. I have a dedicated pattern right now. C++ has completely fallen victim to these categorizations. This is not C++. Core constant expression. A core constant expression is any expression whose evaluation would not evaluate any of the following constructs. Use this pointer, a control flow that passes through a declaration of a block variable. Huh? I can't understand what they say here. Oh, by the way, I was also looking earlier at since I have places in cast now, right? One thing that Rust doesn't have and C++ does is in-place object construction. And apparently the RFC was unaccepted. Rust in-place placement new. Like there was an accepted RFC and then they unaccepted it. They canceled the exception. I don't like have a plan for like placement stuff too yet. All right, I'm not going to. I'm going to think about it a little bit. I'm not right now though. But let me just as a proof of concept have the let here as a pattern, right? yeah, so let's see. I want to have a let. I think macro let should be just let pattern. And this is just the inside of the assignee expression. So I don't need the let pattern be value. We just have the assignment, which assignee equals value, and then the assignee can be a let pattern, which means that this should have a little bit of a higher priority. Maybe, I don't know what exactly the priority be there. We're taking, why do these types have to inherently describe a memory layout? Why do these types have to inherently describe a memory layout? I mean, I'm not describing the memory layout right now. Not really. But what are the things that are strictly tied together? The memory layout and the type, and what? The pattern. So you should be able to pattern match the things. Like I can see myself wanting something like this. You know, like I'm working with like you work with shaders sometimes, right? And you have like a vector, a vec3, like 1, 2, 3. You know, I want to be able to say vec3 xyz equal v, right? But also I want to be able to do like vec3 x, y, and z or something, you know, like with this whistling or something here. So it like something maybe. Or are you talking about different thing? All right, anyway, so let pattern. I'll call this let assign. This is just let assign. Have a dedicated let thing. Let's say that let just has a pattern. Right? This must be an assignee expression. If anything else, then I do something like that. Inject bindings. Okay. Is Irie lightweight? What do you mean lightweight? Irie is just a fork of anyhow. Few lines of code, few def, small tree. No, just I don't know. I know it. No. That's not the priority for them, I think. All right, let's see. If I have let pattern data, I initialize the type inference. It should be the same as the pattern type. Okay. On exhaustive patterns. If I this is done. All right. Sign expression let data. Let data. So when I assign to an assignee expression, which is let pattern data. In this case, I say pattern match, pattern place. I think that's it, right? Yeah. I think that's literally it. Let me see if this works. And since the let X is a standalone thing, I should also be... field now is only present in other. Wait a second, what? While compiling, assign stdlib54. stdlib54. So have this. Let output be this. Okay. What are you saying? Expected type got binding output. Is Irie from Yak? I don't know. There are other alternatives to error handling. Maybe that one is... No, like I say, Irie is just the fork of anyhow. Constlet. Build now and only present in other. Oh, is it because of the constlet? Wait. Constlet. No? Compiler. Constlet. No, it's a different thing. Expected type got binding output. Okay. I don't see the issue. I don't see the issue right now. So, I think I'm going to leave it for next time because I need to end the stream. I'm going to keep this with that to do. All right. It's close to working, but next time. All right, and then I did something. Just very long file. Let me run the tests again. Test very long file is something weird. It's because I did a double stash pop. Okay, but the tests are working. Okay, nice. So this is just assigny expressions. All right, good enough for now. Progress was made. Maybe eventually we get rid of the assigny expressions, place expressions, and pattern, and then we make everything an expression. Maybe. I'll think about it. But that's going to be it for me for today. Thank you guys for watching. Making a 3D voxel game engine. We have another person who is making an engine in Rust, apparently.
Basically, it's an entity control system.
Nice.
We're controlling entities and systems.
More
So
engines
that's why you see things like entities
for Rust.
components and systems,
There's
right?
never
Because
enough,
again, it
right?
controls components and systems.
See you guys next time.
And these
Bye.
components and systems can get attached to entities. Entities can be world objects, characters, literally